Welcome to the Cannabis Cultivation and Science Podcast. I'm your host, Tad Hussey of Kiss Organics. This is the podcast where we discuss the cutting edge of organic growing from a science-based perspective and draw on top experts from around the industry to share their wisdom and knowledge. Before I start the podcast, I wanted to share some exciting news. First and foremost, I'm thrilled to be welcoming a baby girl into our farm family. We are expecting in November, and I will do my best to keep up the podcast schedule, but there's a lot going on, so please be patient with me. In other news, I've been working with Nathan Gibbs and Dr. Ben Higgins from Gold Leaf Gardens on a few different trials ranging from Mammoth P to Blue Mats. I'm hoping to get the data back soon on the Blue Mat versus hand watering trials they've been running in the facility, and we'll share it soon. Ben is also helping me with the Blue Mat designs for beds and facilities, so shoot me an email if you're interested in trying out Blue Mats for your growing setup. For this week's podcast, though, I had the honor of interviewing Dr. Nadia Sabeh, also known as Dr. Greenhouse. She is the president and founder of Dr. Greenhouse, an agricultural and mechanical engineering firm that specializes in the design of HVAC systems for indoor plant environments. Dr. Saba has her PhD in agricultural engineering from the University of Arizona's Controlled Environment Agricultural Center and is a licensed mechanical engineer in the state of California. For over 20 years, she has dedicated her education and career to helping farmers control their environments, allowing them to grow crops indoors, in greenhouses, and in facilities that otherwise would be impossible or impractical to do so. Now on to the show. Hey Nadia, thanks for coming on the show today.
Thanks for having me.
Yeah, let's start off by telling listeners a little bit about your personal journey and how you ended up doing what you do now for a living.
Yeah, sure. So I have been studying and researching and working in controlled environment agriculture for about 21 years now. When I was an undergraduate at UC Davis, I worked on a mushroom farm in southern Idaho, and this farmer was trying to grow shiitake and oyster mushrooms in greenhouses in basically the Nevada climate. And all summer, we could not keep the greenhouses humid enough to grow mushrooms. And so we were constantly just wetting down the floor and, sticking hoses up in the HAF fans just to try to get moisture into these greenhouses. And while working up there, I lived in a little 20-foot trailer right on the farm, and just fell in love with farm life and agriculture. And in that process of trying to control these greenhouses to create a good environment for mushroom production, I had my aha moment and decided that I wanted to help growers, to help farmers control their environment. And so that was the summer of 1998, and ever since I have been on the path to do just that. So I got my master's degree at Penn State studying air circulation in mushroom production farms, which I consider the first vertical farms. And then I went on to get my PhD at the University of Arizona in their Controlled Environment Agriculture Center, where I studied evaporative cooling and ventilation and water use efficiency of commercial tomato production in greenhouses. And after I got my PhD, I decided, I want to learn how to be an engineer. So I left academia to the chagrin of especially my mom, who did not understand why I would leave agriculture and leave the prospects of being a professor and teaching to go out and get a job in mechanical engineering. So that's what I did. I got a real job as a mechanical designer, and learned how to be an HVAC engineer. So I did that for about 10 years, designing HVAC systems for commercial buildings, high-rise residential buildings, even animal shelters became a big part of my work. And then indoor agriculture started to take off. People wanted to grow lettuce and plants in vertical farms and plant factories and containers. And at the same time, cannabis was becoming recreationally legal in Colorado and Washington. And so people wanted to grow plants indoors, regardless of whether it was, vegetables or cannabis and medicine. And so my two worlds collided, agriculture and mechanical engineering. And I decided in 2017, I guess, about 2.5 years ago, to start my own company, Dr. Greenhouse, so that I could live my dream and try to design HVAC systems for indoor plant environments. And so that's what we specialize in, is the HVAC design for controlled environment agriculture, both greenhouses, warehouses, vertical farms, plant factories, containers. It doesn't matter what you grow or what type of building you grow it in. We can help you control your environment better.
Wow, you have quite a dynamic background. I had no idea. I have to say, the reason I reached out to you was because I had multiple people, including Allison Justice, among others, who said, this is the person in the industry that you need to talk to when it comes to controlled environment agriculture and HVAC. So you've gotten a lot of accolades from the people that I really respect in the industry. So I'm honored that you're on the show here. And I wanted to start off sort of talking about some of the goals of HVAC, or controlled environment agriculture, in terms of looking at the main goals of controlling the environment, obviously air movement and odor control as being the three that were sort of highlighted in my head. What do you see as sort of the goals when you step into a facility? What is kind of going through your head in terms of those?
Yeah, sure. So HVAC specifically is an acronym for heating, ventilation, and air conditioning. And really it's about controlling the climate, right? The air's environment that's around people as well as plants and other living organisms. And for an indoor plant environment, what we're really trying to do is it's kind of a two-pronged design or set of controlled parameters. One is the climate itself. So we're trying to control temperature and humidity and the vapor pressure deficit. And in order to control the plant's responses to the temperature and humidity in the space, which affects transpiration rates, photosynthetic rates, metabolic rates of the plant, and so the general health and growth of your crop. But in addition to just temperature and humidity, we're also trying to control the air quality, and the quality includes things like carbon dioxide and odor and VOCs, as well as the movement of the air around the plant and pathogens. So the particles, basically, right? The things that are actually inside the air that's around your plant. And so HVAC, we're controlling temperature and humidity and that climate, as well as the air quality that's surrounding your plant. And all of that relates to the health and productivity of the crop and of your final product and how quickly that product grows. So it's both yield as well as those quality characteristics.
Yeah, I realize it's a very complex topic, which is why we have to hire experts like you to come in and assist. I guess what I'm wondering is, so what would be some of the challenges just starting off with for a basic home grower? Let's say I had a 4x4 and 8x4 tent, and I want to set up a small little grow room inside of another room. The way I was always taught was you want to have a fan, let's just say a 6-inch inline ducting fan. This is back in the day when we had single-ended air-cooled hoods, and I would run negative pressure by pulling the air out of the room and through a carbon filter in the process. What would you look to set up if on the small scale for the homegrown listeners? What sort of tips and pointers might you have along those lines?
Yeah, I think that regardless of what scale that you're growing at, whether it's small or it's medium or it's commercial, large scale, that really the parameters are the same, but the scale is a little bit different. And so when you're setting up a smaller grow, you don't have as many inputs from the lights, from the plants, from the irrigation system, or even from the surrounding environment. If you are, say, in a tent grow, or if you're in your garage, you have a lot fewer variables. You have the same variables, but you have less intensity of them, I guess you could say. So, if you have 6 plants for one high pressure sodium lamp, it's very easy to document the amount of heat that's going to be generated by that lamp. You have a small, wall area, so you don't have to worry too much about what's going on outside. And your plants are getting a certain amount of water that you are controlling, very regularly. And you probably know exactly how often you're watering and how much your plants are using. And you can touch and feel the soil to know when they need to be watered next. And so for those, smaller facilities, those small home grows, the HVAC equipment that you can use to control the environment can be relatively simple, right? I mean, it's going to be the air conditioner, say it's just like a split system heat pump. I see this pretty commonly in home grows where you just have, like the condensing unit outside and you have a fan coil unit inside, and it's just enough heat or it's just enough cooling to remove the heat generated by the lights. And maybe it's hot outside, so it can do that too. And then you might have, one small dehumidifier in the space to remove the moisture that's being generated by the plants. And then you have a fan, right, that's blowing air around the plants to make sure that they're moving, make sure that you're transferring, the carbon dioxide to the plants, and also removing water from transpiration, heat away from the plant, maybe from the radiation from those lamps. And, you kind of need like one of everything, right? You need one fan coil unit, one fan, one light, one pump for irrigation or your hand, one hose. And it's relatively simple. But as you scale up, it gets a little bit more complicated because the dynamics get a little bit different. Now you have a larger roof, say, and bigger walls. And so the interaction with the outside environment might be a lot greater. And now you have a lot of lights, right? So let's say you went from 50 square feet up to 500 square feet. Well, now you have, 10 times or maybe more the number of lights than what you were used to. And now you have more plants, and you're watering them probably more frequently or in a different way. Maybe you're using drip irrigation and maybe even like a rock wool type of system. And so you have a more constant flow of water. And now all of a sudden, maybe one of everything isn't enough, at least if you use the same system that you were used to. And so that, I think, becomes a real challenge for growers who are scaling up, is that they were used to a certain type of system and used to a certain type of setup that worked very well. But now as you get into these bigger facilities, you need to multiply everything. And if you stick with the same type of system, say the same type of HVAC system, now maybe we have, 10 fans and 10 fan coil units, 10 little air conditioners, and that becomes a real maintenance challenge. The other thing is that, those fans that you might have had sitting, on your wall, or a little floor stand fan, that can't reach very far, right? And in 50 square feet, it only has to maybe reach 10 feet away, right? It's 10 feet by 5 feet maybe if you're in a 50 square foot little tent. But now you're in, 500 square feet, and now it's 10 by 50. And that fan can't blow 10 feet away or 50 feet away. And so now you have to maybe think more about, how am I going to get air to the middle of the crop so that the plants in the middle can dance, as well as the plants close to the fans, close to the walls. And same with the air conditioning system is, I've been on the phone with farmers who have these fan coil units, right? And these are those systems that are mounted on the wall, and they just have a little fan in them and a little cooling coil, and they're circulating the air that's in the space and, sucking it out the bottom and then blowing it out the side, cooler, drier air. Well, now if you need, one of those in your tent was great, right? Like that's easy to maintain. You can buy it at Home Depot, no problem, pretty cheap. But now think if you have 10 of these things in a space, all of a sudden it becomes kind of a maintenance nightmare. I was on the phone with a farmer one time back east in Massachusetts, and he's like, yeah, we inherited this facility, and all of our grow rooms are 500 square feet, and we have like 10 or 12 of these, fan coil units on the wall in every single room, and so we have like 180 of them total in the facility, and they break down all the time. I'm constantly changing the fan motors or, the little coil pumps on them. And they just become really challenging if you try to scale up that same system that you were used to in a small grow. But there are solutions where you could still do one system per 500 square foot, or even one system per 2,000 square feet. And these are larger HVAC systems. They can be package systems that sit on the roof or outside of the facility. And it's an all-in-one. And now what you can do with that system is you can actually duct air from them. So now you stick, a duct on the end of that, and you can blow that air over the top of the canopy. And rather than relying so heavily on fans to move air around, now you can use ducts. They can either be hard metal ducts or they can be fabric ducts. And you can be strategic about blowing that conditioned air down over your crop wherever your plants are. And so that helps to solve some of the issue with air distribution that you're going to experience with a larger facility. I would say, in general, while I'm on the topic of air circulation, that is one of the biggest challenges, and is very important for plants, because I had mentioned earlier that, it's responsible for taking away the heat and the moisture from the leaves and from the plant so that they can continue to transpire and they don't get too hot. But also, you think about it, they're also going to deliver CO2 to the plant, right? So the plants are generating oxygen. They need CO2 to photosynthesize. And so, moving air across the plants is really important in an indoor facility. And when we get bigger rooms, it gets harder to move air. But also, a lot of farmers are now going vertical, right? They want to take more advantage of the vertical space in a warehouse. So rather than having rooms that are, 10 or 12 or 14 or 16 feet tall, now they want to take full advantage of their 20-foot or 25-foot tall warehouse and double stacking them. And now when we talk about vertically stacked plants, now we're not just having to deal with moving air horizontally. Now we have to move air, vertically, right, at multiple levels. And that's an even more special challenge to figure out, how do I create even air movement left and right, as well as from top to bottom. So that, those are sort of some of the bigger challenges associated with scaling. So starting with a small facility, it can be relatively simple. Stepping up into sort of a medium-sized facility is challenging, but maybe easier than even getting into, say, a 10,000 square foot room or a 2,000 square foot room that's vertically stacked. The big challenge becomes moving air and getting it out of the space before that humidity and that heat build up.
Yeah, you talk about air circulation. I think that is such a fascinating topic that I'm frankly pretty ignorant on. I do see an issue though, like you mentioned. So you'll have, you walk into a growing space and you'll have fans blowing, a varied amount of air, and typically from above down onto the crop or fairly close to the height of the canopy. And I know when I visit a lot of these, you'll see leaf burn from the wind where the plant can't transpire fast enough to keep up with how quickly the air is moving across that leaf right near the fan. But then as you move further away from the fan, like you said, you're not getting that airflow that you need for that plant. So what are some ways that you fix this? I know you mentioned those ducting options. I've seen those, the fabric ducts that you can run down the aisles. But for with a more traditional fan-based approach, are there any tips and tricks in terms of where you should be positioning your fans? Or is there I know we have flow meters for water. Are there ones for air that we can use to measure or optimize our fan placement in a room?
Yeah, I mean, that's a really good question. And, that's something that we will do is air or is fan design. So we've actually found that using traditional greenhouse horizontal airflow fans work pretty well at mixing the air. There's kind of two aspects of air movement. One is, what I've been talking about moving air across the plants themselves, breaking up the boundary layer around the leaves, because basically this pocket of moisture and heat sort of develop around the leaf, and we want to break that up and facilitate gas exchange. But the other thing is just mixing and getting a uniform environment around the entire facility. And so using horizontal airflow fans, creating sort of this circular pattern around, the tops of the crop can really help to mix the air, because, you have the lights and you have fans and you have motors and you have stuff that's sitting above the crop. And then you have the crop down below, that's hopefully transpiring and is cooler and more humid. And by having these fans circulating above, it actually helps to break up the boundary layer between the hot and the cold blocks of air that develop vertically, right? I mean, everybody knows that hot air rises, and that can be good when you have a lot of heat being generated from the lights. But also, water vapor is less dense than air, as is carbon dioxide. And so that humidity and that CO2 actually, so the CO2 will kind of, sink down to the ground, and the humidity will actually rise. That water vapor will rise up with the heat, which is a good thing in general. And so using the HAF fans to mix things up and sort of, they actually will act to sort of help to suck the moisture and the heat up from the top of the canopy while also moving the top of the canopy. And, a lot of people are really concerned about having, air movement down below and that, underneath the canopy or at the lower levels of the canopy. And that's true. I mean, it is important to move air, to circulate air lower in the canopy. But, if you're doing a good job of pruning and you don't have a lot of leaf material, sort of in the lower half of your crop, then you really don't need that much air movement down below. Your plants grow from the top, right? And the flowers are at the top. And so really air movement at the top of the canopy is the most critical place to create that gas exchange, to create that air movement, because that's where all the activity is happening. That's where all the photosynthesis is happening. That's where, the powdery mildew is going to want to live, on the flowers at the top of the canopy. And so having that air movement above the crop and at the top of the crop is really more critical than having it from below. Air circulation is really important. And, so I mentioned horizontal airflow fans, but also, ducts in general. I mean, there's a science, but also there's sort of the art in HVAC engineering of air distribution design. And a lot of people don't realize that the diffusers, if you look up in your ceiling at home or in the office or whatever, and you look at the diffusers, those are hopefully selected specifically for the environment that they are trying to control. So, there's a certain throw pattern, there's a certain velocity there's a certain way that air moves out of the different diffusers that are available to us, so that by the time the air gets down to, say, your desk where you're sitting, it's mixed with the air above, and it's the perfect sort of temperature and velocity as to not create a draft or make you uncomfortable in your workspace. Well, we can do the same exact thing with plants. We can actually be selective with the types of diffusers and the location of those diffusers relative to each other and relative to the tops of the plants to create the environment that we want at the top of the plant. Unfortunately, not a lot of engineers, I think, take the time or really understand air distribution design, even for a commercial building, I'll be honest. And, a lot of the contractors, too, who may be installing those ducts and those diffusers, are probably not thinking a lot about that either. But there is some science behind that. There can be a method to the madness in how those diffusers are selected and located that can create a more uniform environment for you. The other thing is that, I'll be honest, I've been pretty impressed with fabric ducts. There's a few different manufacturers that create a good fabric duct. And what I like about them is that if you find the right company and the right representative of that company, they will actually ask, well, what is the velocity of the air that you want at the distance, that your plant is from where the duct is going to be installed. And they will literally engineer the holes in those ducts, the holes and the nozzles and the perforations associated with that duct sock or that fabric duct to create the velocity of air that you want at the canopy level. I've been very impressed with the companies that I've worked with. I mentioned Duct Socks, that's one of them. And they will work with you. If you say, look, I want 1 meter per second at the top of my canopy, and my duct is going to be 8 feet away from the top of my canopy, can you do that? Yes, actually, they probably can. So, air distribution design does not necessarily have to be a black box, and it doesn't necessarily have to be haphazard in a way that now we have to throw a whole bunch of fans into the room to blow air around because the engineer or the contractor or the, duct supplier wasn't really asking the right questions or putting thought into the design. We can design it pretty specifically to create the environment that we want.
Okay, I have a bunch of questions from that last comment, but
awesome.
I want to start with these duct socks. So, as someone who works with soils indoors in a lot of these facilities, I just picture it being a dust and even like mite or pathogen magnet in a lot of ways, to where cleaning would be very difficult. What are your thoughts on that?
Yeah. Okay. So let's talk about ducts in general and their propensity, potentially, for being a harbor for pathogens. So I've heard both. I've heard some people say that metal ducts can be a harbor for pathogens, and I've heard some people say fabric ducts can be a harbor for pathogens. And honestly, the answer is both, right? So with metal ducts, one concern is that, when they're metal, then water can condense on them, and then you can have dripping, and then you have, sort of a free surface of water that pathogens love to live in. So 2 thoughts. One, if your duct is dripping wet, then you are not controlling humidity. The temperature that's in your space should be, if you're controlling humidity, should be below the dew point, should be above the dew point temperature of the air that's traveling through your duct. So dew point is the temperature at which condensation happens, right? It's when dew is produced out of the air. So basically, you have moisture in the air, and then you have a cold surface, and that cold surface is at or below dew point, and so that water condenses out of the air and onto that surface. So you see that, with a glass of ice water on a warm, humid day in Texas or anywhere except basically California. And so that's what's happening is that, with these supply ducts, you have, cold air coming out of your air conditioner, and then in the facility, you have, warm, moist air that's being developed. So if you're not able to control dew point in your room very well, then yes, water can condense on that cold surface of the duct. If you're controlling humidity well, then I would argue that would never happen. Now, to avoid that, if you don't want to risk that at all, you can insulate that duct. And that would be very common in your office building, in a commercial building. You insulate that duct. And honestly, there's a couple of good reasons to insulate your duct. One is to prevent that risk of condensation, but the other is to make sure that the temperature that's delivered to your room is the same from beginning to end, right? I mean, if you think about you're blowing, say, 2,000 CFM of air down a duct, and that air is going to travel 100 feet. If that duct is inside your room, it's being bombarded with light. It's being bombarded with maybe that condensation could occur or whatever. And so by the time it's traveled, that air has traveled from the air conditioner 100 feet to the other end of the room, it could be 2 to 5 degrees warmer. But if you insulate the duct, it's going to be the same temperature from end to end, and you've eliminated that risk of condensation. So that's the metal duct in terms of pathogen risk and just condensation in general. Fabric ducts, I mean, it's kind of the same idea, right? I mean, is that fabric duct going to collect water, which is inviting to pathogens? Well, I would, maybe. But the good thing about, again, it goes back to the air that's traveling through your duct and the air that's in the room that's then interacting with the surface of that duct. And so it's sort of the same thing, except that fabric is not as conductive to heat transfer as metal is. So metal is very conductive to heat. And so it's going to maybe have a higher propensity to condense water, where fabric is, doesn't really conduct heat that much. Same like if you took aluminum versus wood, right? I mean, aluminum, it gets hot and cold very quickly, where wood, it basically stays the same temperature until you catch it on fire. So fabric is sort of like, you could think of kind of like wood. Like it's basically going to stay the same temperature. However, I think I do have the concern about fabric ducts in the sense of what I talked about, the temperature gradient from end to end, is that it's a lot harder to insulate that fabric duct. And in fact, you don't want to insulate the fabric duct because it's perforated. And if you insulate it, you're going to block all those holes. So, for very long runs of fabric duct, you could see a temperature gradient from end to end. Now, what some people really like about fabric ducts is that they can wash them. So, you can purchase them in sections, and they basically zip up and unzip, and you can take out sections and you can throw them in the washing machine. With that said, do people actually do that? I don't know. But at least the option is there. And maybe you need an industrial size washing machine as well to do that. So, and think about, if you don't have extra pieces on hand, then you may have some downtime, unless you can just replace it while you're washing, those ducts. Or maybe you do want downtime for a week or a few days just to clean out the room before the next crop comes in. So, there's pros and cons to everything. And I think, both can be good solutions and don't have to harbor pathogens. They don't have to get dirty and get a lot of condensation if we're able to control the room the way we want to control the room.
Okay, so if we go back to talking about airflow in terms of measurement tools, you mentioned that you could say to a ducting company, I want 1 meter per second this distance away at on the canopy here. How did you get that 1 meter per second? Like, what's optimal for cannabis in general? Or do we know? I've heard ranges of like 3 to 5 miles per hour, but to me that doesn't mean anything. Like, I have no idea what that would look like. How is there a tool that the growers can use that's reasonably affordable to go into a room and check different places, like say we can do with a light meter, for example?
Sure. So yes. So first off, half a meter to 1 meter per second is equivalent to 100 to 200 feet per minute, which is equivalent to 1 to 2 miles per hour. So half a meter per second to 1 meter per second is equivalent to 100 to 200 feet per minute, which is equivalent to 1 to 2 miles per hour. And now, this is not necessarily gospel. Where this number comes from is from vertical farming and plant factories. That what we have found is, at least for leafy greens, for lettuce plants and basil plants, that as long as we're able to grow the plant within that range of air velocity, that we eliminate leaf tip burn, right? And get the highest rates of photosynthesis and productivity and yields. So it's a quality characteristic. So within that range, we know that we have good transpiration through the plant, which is why we're not seeing leaf tip burn. And we're getting a good amount of carbon dioxide to the crop, which is allowing for good photosynthesis. So it's really based on lettuce crops, honestly. And those lettuce crops, are dense, right? If you think about a head of lettuce, those leaves are very close together. And so, we're saying that, 2 miles per hour wind speed is good for this dense crop. Well, cannabis, honestly, unless you have a dense crop, and some people do, sea of green, they don't prune a lot. They really, maybe vegetative plants, you really want a lot of leaf area. I don't see why it would be a different number for a cannabis leaf than it would be, say, for a lettuce leaf. Though I'm sure a lot of people may argue with me on that, and that's fine. The whole idea is that we want to move air across the plant. We don't want stagnant air because our plants won't transpire and they won't photosynthesize as effectively. So that's where that number comes from, and I think because that's the only documented research, that it's the place to start. Whether you can have an airspeed that's too high, I'm not sure. It's possible that the air velocity could be too high and the plant starts to close its stomata to prevent too much water loss, right? And so then if that happens, then we're shutting down transpiration or slowing down transpiration, and then that effectively reduces nutrient transport, might increase nutrient deficiencies, slow down photosynthesis, right? And same on the other side, is that if the air velocity is too low, then that pocket of air, that pocket of moisture will just build up around the stomata and around the leaf so that it can't effectively exchange water vapor away from the plant and CO2 into the plant. So just based on the documented research, we know that half a meter per second to 1 meter per second is a good place to start, at least with horticultural crops. So until somebody does the research on cannabis plants, I'm sticking to the research that I can find on horticulture.
Yeah. Now, does that research account for the addition of CO2 at fairly high levels into the room, which I assume would affect
Yes.
your airflow and things like that?
Yes. So again, I mentioned that, air movement is responsible for gas exchange, period. And gas exchange being, water vapor away from the plant and CO2 to the plant. And so, as long as your environment is enriched and we have that good mixing from fans around the room and all that CO2 hasn't sunk to the floor and can find its way up to the leaves and to the top of the canopy, then that air movement is going to help deliver that CO2 to the leaves. And I don't know that if it's too high that the CO2 is going to blow right by the leaf, as long as we have a good enriched environment. But certainly, if the air velocity is too low, then the CO2 might not make it to every plant evenly.
And how are you measuring this again? What tool are you using for that?
Sure. So the tool that we use to measure air velocity is called an anemometer. So there's vane anemometers and there's hot wire anemometers. Vane anemometers tend to measure airspeed at a higher air velocity, so 50 miles per hour, no, that's too high. 50 feet per minute and higher, usually closer to the 100 to 200 feet per minute and higher is where they really is their sweet spot. And the vane anemometers sound like that, like they have the vanes of a fan. It looks like a little fan, and you can stick it in front of a fan. It'll turn, right, like a little windmill. A hot wire anemometer is what it sounds like. It's a wire, and it basically sends a current based on the wind velocity. It will change the current, the amperage current, to the meter, and that gets converted into a reading of air velocity. And so hot wire anemometers, they work at high velocities, but they actually work really well at low velocities, a lot of times at like 10 feet per minute. And so you can really, for these lower air speeds that we're trying to get across the plants, a hot wire anemometer is really the tool that growers should use and engineers should use to sort of spot measure what the air velocity is at the top of the canopy, in the middle, and the bottom. They use them in the ductings. You can stick them in the ducted system as well. It's like a long little tube. So a lot of contractors use a hot wire anemometer even to calibrate the fan speed from HVAC equipment to make sure that you're getting the right amount of airflow through the duct.
Thank you for explaining that. One other question I had along this idea of air exchange is when I talk to a lot of growers, there's sort of a debate between sealed versus unsealed rooms, with a lot more growers moving towards sealed rooms. So I wanted to have you touch a little bit about that. But then the other thing I hear about is when people are running unsealed rooms, they talk about air exchange, like they're exchanging the air in the room this many times per hour. How important is that air exchange from, to look at it from that perspective? Because everything that you're talking about right now is really sort of that movement around the room itself. How important is it to get that air out of the room?
Right. So yeah, I mean, so let's first off talk about the difference between air velocity and air volume. So air velocity is that speed, right? The wind speed, say across your plant. So we just said, 100 to 200 feet per minute in that range. Air volume is spoken of in CFM, or cubic feet per minute. So that's the total volume of air that gets delivered, say, from your HVAC system through your duct and into your room. It doesn't become air velocity until, we actually measure the speed of that air. So I just want to make sure that everybody understands that distinction, because sometimes I hear people use CFM or the CFM interchangeably with velocity. The velocity is feet per minute and volume is CFM. So I just wanted to make that distinction first. So, all right, sealed versus unsealed rooms. Yes, I understand why people want sealed rooms. There's generally, I would say, 3 reasons to have a completely recirculating air conditioning system. The ones that I hear are, 1, we want to prevent any contaminants from coming into the facility through the air handling system, right? The second reason is for odor control. And I know we're going to talk on odor control a little bit later, but we want to keep odors out. And if we ventilate, if we bring air in, then that means we also have to take air out, and that odor, has, or that air has odors, which is offensive to our neighbors and to, the building department who's going to give us our permit. And the third reason is carbon dioxide, right? Is that if we're enriching this environment with CO2, we don't want to just dump it out through the ventilation system. We're spending money on that CO2, and so we want to keep it contained. So the unsealed rooms, though, the rooms that have some ventilation air, for me, check a few boxes. And I actually like to design facilities that have at least the option for ventilation air and are not 100% recirculating. And there's a few reasons for that. One is that building permit, is that, the building code, the commercial and residential building codes, and right now we're sort of in this weird gray area where all the building departments are trying to figure out how to regulate these buildings and whether it should meet the same standards or higher standards or lower standards, right? So the commercial building code has a requirement that you have to provide a certain amount of ventilation air for people. So we know there's all sorts of studies that show that at elevated carbon dioxide levels, people are less productive. People don't think as well when CO2 levels are just as high as 600 or 800 parts per million. And so, the building codes have a requirement to provide at least some fresh outside air to keep CO2 levels down, at least below 1,000 parts per million, so people have a healthy environment to work in and are more productive. Okay. And so by having some ventilation air to meet just minimum building code requirements, checks that box. To me, that means that a building inspector isn't going to come back through and say, hey, why aren't you meeting our ventilation code requirements? I'm not giving you a permit until you change that. That would be a huge disruption to your construction schedule and your operation schedule. So rather than guessing or hoping that they're not going to have that requirement, I'd rather just build it in. Because usually it's a very small amount of air. In California, it would be equivalent to 0.15 CFM per square foot. For a 10,000 square foot room, that's like 1,500 CFM out of a total of 150,000 CFM. Think about that. It's 2,000 CFM versus 150,000 CFM. I mean, that's like nothing, but it checks the box for the code official. So that's the first thing. The second thing is that what if your CO2 enrichment system goes down? Right? How are you going to feed your plants if you run out of liquid CO2? Or if now, in the future, the building inspector decides you can't use CO2 burners in your facility. How do you get CO2 into your room? I worked with a vertical farming client a couple years ago, and they were trying to figure out why their plants wouldn't grow. And so, I'm on the phone with them for a couple hours. We're going through everything. Okay, what's the temperature? Okay, we're looking at the data, right? The historical data. The temperature is right on target. The relative humidity is right on target. They're irrigating. The lights are working how they thought they should be working. We're going through all these different variables. And finally, I just asked this question, you guys are enriching with CO2, right? And it was just silence on the other side. And they're like, oh. And they had a completely sealed environment and were not ventilating or enriching with CO2. And they went up, they pulled up the data, and the CO2 level in their vertical farm was 200 parts per million. Their plants didn't have any food.
Yeah.
So when people say, I want a sealed environment because I want to keep CO2 in, I always ask the question, well, what happens when you don't have any CO2? If you have some ventilation air, it doesn't take that much to bring CO2 in. Yes, we're ventilating air because we're trying to kick CO2 out for people, but it's also bringing CO2 in that your plants are using for photosynthesis. And so, again, at least building it into your system, even as an option, even if you close the dampers, fine. Let's close them and keep it sealed. But if you have the option to open them up to let ventilation air in, you may be really happy one day that you gave yourself that option. And the third thing is, in some climates, in some climate zones, having the availability of outside air to condition your space could be an energy savings measure for you. If you live in a location where it can be cool and dry, Colorado, perfect example, can be cool and dry during a lot of the year, you can actually bring that outside air in to air condition and dehumidify your space. And now all you're doing is running a fan as opposed to a bunch of air conditioning compressors. And you could actually reduce, your energy use by, 80% in any given hour because the only thing you're running are fans and not compressors. So, I think, but that doesn't work for every climate zone, right? I mean, if you're in Hawaii or if you're in Texas, there's probably not a lot of time where that's available to you to use outside air, and so that wouldn't make sense. But yeah, using or at least having the option for outside air, I think is a really good idea. And in terms of contamination and bringing in, pathogens and pests into the building, I get it. But, there's not as much in the air as people think there is. I'm of the school of thought that people transfer pests and pathogens, not the air, right? People who have those home grows, that 6-plant, 1-light tent grow at home and then come into the 5,000 square foot grow facility and don't put on gloves, don't change out of their street clothes, and just start touching plants, that's where powdery mildew comes from. It's not coming from, your air conditioning system that has filters on it. And while I'm talking about filters, while I'm on the topic, I do want to say that all you really need in terms of filters to keep mold spores out of your facility is a MERV 13 filter. You do not need HEPA filtration to keep mold spores out of your facilities. HEPA filters are great if you're concerned about viruses. But if you're concerned about botrytis and powdery mildew, then all you need is a MERV 13 filter. But I will say that you should also install a MERV 8 filter before your MERV 13 filter so that it can catch all the dust particles and let your MERV 13 filter just catch all the spore particles. So I want to make that plug on filters because HEPAs are just overkill.
Oh, that's great. I do wonder, though, what about pesticide drift? Because that's another reason to avoid air exchange potentially as well if you were in, agricultural area and you're worried about what the farmer next door is spraying.
Absolutely. Pesticide drift, honestly, it's so interesting to me in this industry. I've never heard concerns about pesticide drift in mushroom production or in commercial tomato production or pepper production or lettuce production. Pesticide drift is not something that people are thinking about. And, I'm guessing the reason pesticide drift is so important for cannabis growers is because if you get a lab test that says that you have pesticide residue on it, you're out, right? But if you're a tomato grower, that's not an issue for you. And so I find that pesticide drift challenge really interesting. And yeah, I mean, especially with greenhouses, if you're trying to use conventional, ventilation or pad and fan systems, and you are close to a farm or in an agricultural area where your neighbors might be using pesticides or other sort of chemical fertilizers either, then I would say that is definitely a concern. Now, there's a couple things about that. One is you could get to know your neighbors and make friends with them and find out when they're going to spray, right? And, there are rules and regulations about when you're allowed to spray. You're not allowed to spray during inversion layers because it just keeps it all down, right? And it can't, get out of the air, what am I trying to say? Down near, the human-occupied zone. And you also, I'm pretty sure most farmers don't want to spray on windy days because they're going to lose a lot of the chemicals to their neighbors, or it's not going to get on their crop like they want it to, right? So in getting to know your neighbors who might be field farmers and might be spraying fertilizers and pesticides on their crop, is if you have a good relationship with them and you know when they're going to spray, you could take that into account in terms of your operation, right? Is that if they're not spraying today and it's a beautiful, cool, dry day, then open up your air conditioner, right? Let outside air come in all you want, all you can to reduce energy and supplement with CO2 and save on that. And then, tomorrow, and then you have a phone call with your neighbor and he's like, hey, I'm going to spray tomorrow. It's like the perfect conditions to do that. And you say, hey, thanks, Joe. Thanks for letting me know. And then that day you can close it up and do 100% recirculating system. So, I totally get the concern, but I think there are sort of ways to work within, the agricultural regulations as well as, just having a good relationship with the neighbors around you that might be doing spray applications.
Yeah, I'm hopeful though that this industry, the cannabis industry, can potentially be a catalyst for some change within our greater agricultural industry and looking at some of these rules and regulations.
Totally.
It's an issue. Like just 2 weeks ago, this is a little bit of a tangent, but I had a lady contact me about heavy metal levels in compost. And so I called the Washington State Department of Ag, and basically I was told that as long as you're a soil amendment, they're not testing for heavy metals. And compost is just sold as, primarily for gardens, so primarily for vegetables. So then I called the Oregon Department of Ag, and they told me that if you're putting it into a bag, then they do have some requirements and testing around that. But they had set the level at 247 ppm. It was somewhere right around there for lead. That lead was the one we were concerned about with this particular product. And basically what I was told is that level was set by someone that was contracted by the, I guess it was the FDA originally as an outside consulting group. And I was like, can you send me the research as to why they came up with this very specific number that was allowed in crops? Because I would assume if you were growing cannabis or a root crop, it would have higher levels of heavy metal uptake. And I haven't gotten that research yet, but it made me realize that sometimes I am a little too trusting about things and assume that, the government's looking out for me on this stuff. But in reality, that may not be the case. And I think pesticide drift kind of falls into that category. But
I would totally agree with you in that. I think that the cannabis industry is a catalyst for change and for technology development and regulation development in general, and I think will all be for the public good and for the building up and evolution of agriculture in general. Because agriculture is moving indoors, or some of it is and will. Even if we're not growing wheat indoors, fine. But if we're growing, vitamin-rich crops indoors, then, the things that we're learning from track and trace and from organic certification and from pesticide use, I think a lot of that, is going to transfer over, from cannabis to indoor agriculture in general, as well as technology. I mean, there's so much of us in the industry who are so grateful for cannabis because we're getting rapid R&D on things like lighting and irrigation systems and HVAC systems, and these equipment and systems that can be more focused on growing plants indoors, aka horticulture. And what's good for cannabis is good for the rest of the industry. It's even a training ground, right? I mean, for future farmers, is that a lot of young people are growing cannabis, and I've talked to so many of them who have either moved into more traditional horticulture and are growing tomatoes and lettuce, or who want to eventually. So it's very exciting. Those of us in indoor agriculture, controlled environment agriculture in general, see a lot of crossover and see a lot of benefits coming from cannabis for agriculture and horticulture at large.
Yeah, I totally agree with that. I love that it's a gateway drug now for vegetable gardening. So I enjoy that
gateway drug for farming. I love it.
Yeah. So one question I had when you were getting back to the sealed versus unsealed room concept.
Sure.
When you were talking about that, we're kind of talking about one entity, just like one room. But what in my head I'm picturing is, let's say, a 10,000 square foot building that then has, maybe 6 1,000 square foot sealed rooms inside of that building. So we have air exchange outside, but like I was just in a facility, a metal warehouse in Oklahoma, for example, where you have temperature extremes. You may have 102-degree temperatures outside at some point, and you might be below freezing at other points during the season. And, just while I was there was, I think, a 20-degree temperature swing to where I would think we'd want to have, at least where we're growing the plants, more of a sealed room, and then maybe air exchange into a larger area where the temperature isn't quite as controlled, where, say, a lot of the processing and packaging and admin stuff is going on. I mean, what are your thoughts around that sort of a setup?
Yeah, I mean, so many facilities are being built as sort of rooms within a room, right? Or rooms within a building, where you have insulated panel walls of some sort that are built into a warehouse, which, the warehouse exterior walls and roof are having the direct interaction with the outside. And then you have, these insulated rooms that are interacting more with the inside of the warehouse, which may or may not be controlled, but is probably tempered at least from what's happening outside. And those sealed rooms are great in terms of heat transfer, right, and moisture transfer. We know that we're not going to have a lot of heat leaving the walls and the roof, or even water vapor transferring through, which can make humidity control really challenging because of those insulated panel walls. And that's a good thing, because the more that we can control the gains and losses across the envelope, the more predictable it's going to be what the loads are at any given time from the plants and the lights and the fans and everything. Now, in terms of, now the warehouse building itself, can be insulated. We don't necessarily have to have these insulated walls, these rooms built into a warehouse using that panel system. We can do more sort of traditional construction, and we can build out, partitioning walls within the warehouse and have them insulated. I would recommend using rigid insulation and metal stud walls as opposed to wood and bat insulation, which will have a greater propensity to grow mold and get wet. But then in terms of interaction with the rest of the facility, so if you say have 6 grow rooms, and then you have a common corridor, and then you have all the post-harvest packaging and drying and office areas, the way that I like to design a facility like that is to make those grow rooms slightly positively pressurized. And this becomes a fourth good reason for bringing in outside air, is that we can positively pressurize these rooms so that we can keep contaminants out. So if you imagine, just say 4 rooms, 2 across from each other, split by a common corridor, and if those 2 grow rooms have slightly more air that's blown into them than what's in, say, that common corridor, then that air is going to want to push out of those rooms and, say, under the cracks of the doors, right? The door jams. And every time you open the door to go into the facility, air will push out of it. And by creating that positive pressure, pathogens and bugs, they like to follow the path of least resistance, right? They kind of go with the flow. And so if you open a door and air is pushing back on them, they're not going to push against that. They're not going to, go into that room unless they're stuck on you, say. And so, positively pressurizing that room and then having a corridor that's maybe slightly negatively pressurized. So you have a little bit more suckage in the corridor so that then it's pulling that air out of the building. And then you can run that air through a carbon filter before, it leaves the building, or as it's leaving the building, so that you prevent the odors from leaving. So, yeah, I don't know if that answers your question.
Yeah, that's sort of what I was thinking, is positive pressure in the rooms, negative pressure in the larger building. And then you're not trying to odor control each room because you don't care if the facility smells. You just don't want to, tick off your neighbors or get a complaint outside the facility. But I like smaller rooms because you can adjust them. Each room is slightly adjustable. It allows you to separate the plants and sort of keep different issues in different rooms. So if you have thrips in room 1, you don't necessarily have to have thrips in your entire crop. Room 2 could still be clean, or room 3. And in addition to that, along those lines.
Yeah, I tend to like smaller rooms too. I mean, they don't have to be super small. Maybe 500 square feet, is kind of the lower end of the size of a room that I might like to see. But I think 10,000 square feet is too big. I think 5,000 square feet is probably too big. I think somewhere between 1,000 and 2,000 square feet feels to me like the right size. And, you mentioned containment for pathogens, right? Is that if you get a room that gets infected or contaminated with thrips or powdery mildew, then it's contained to a small room and, or to a small yield and crop. And so then you can just take that crop and run it through extraction and call it a day, right? Then maybe you don't completely lose everything. And the other thing too is that I think something that's totally overlooked, or too often overlooked, is when you have a really big room, that usually means that you have a lot of different cultivars or strains in that room, right? I mean, if you think about, you have 1,000 square foot room and maybe it has 2 different cultivars in that room. Well, now if you have a 10,000 square foot room, does that mean you have 20 different strains in that room? And how do you control the temperature and the humidity and the lighting levels and the irrigation even and the nutrient mix for all those different strains? Which, you have indica and you have sativa and you have hybrids and you have an indica that grows like a sativa, or you have a sativa that grows like an indica, right? Like, how are you supposed to control all those variables for the very specific breed of plants that you have when you have a lot of them? If you have a smaller room, and maybe you can actually schedule the cultivation of 2 strains that physiologically like the same environment, right? Like the same levels of light, like the same temperature and humidity, like the same nutrient mix. And now you can really dial in the conditions specifically for that one or two or maybe three strains. How beautiful would that be if we could actually optimize the environment for the plant, right? As opposed to what most growers do is they're like, okay, we have 6 strains in here, and we do that because the market likes these 6 strains or because we're testing a new strain or whatever. And they're constantly hitting the accelerator and pushing the brake at the same time, right? I mean, you can't, by trying to make everybody happy, you make nobody happy, right? I mean, that is so true for these plants, is that you end up picking a temperature and humidity and a lighting level that isn't really optimized for any of those strains. It's just optimal for keeping them happy, but not, joyful, if I could use that analogy. And so, I think, having smaller rooms and focusing your environment on just one or two really similar physiological strains, I think growers would be really surprised by how well their plants would do, how well they would respond to the perfect level of PPFD, and the perfect vapor pressure deficit, that they were bred, quite honestly, to thrive in, right? I mean, you didn't call on me for a discussion on breeding, but if you think about where so many of these crops have come from, they were bred for very specific environments, for their specific grower and their specific conditions and their specific equipment and their specific climate outside, and then we try to shove them into our box, and they don't respond the same because we don't have the same parameters or the same control or an understanding of what those plants were specifically bred to thrive in. So I think there's a lot that can go into breeding. I think more people are getting into it, which is great. I love it when I talk to people who are growing in greenhouses and they're like, yeah, we are actively working on breeding plants to grow in a greenhouse environment, as opposed to trying to take an indoor strain and ask it to grow well in a greenhouse, which is completely different than an indoor facility.
Sure. We do. We have a ton of genetic diversity right now in cannabis with this plant. And so you bring up some really good points there. And I would add that by going with these smaller rooms, we can control workflows better too. So we could harvest, say, each room every 10 to 14 days or whatever schedule makes sense. And then we don't have plants of different ages going into a giant room where we will never get control of a pest or pathogen in. And we don't have the ability to really clean the room if you're going with the perpetual harvest, which is why I don't like these big rooms. And it does sound like from HVAC perspective, there are challenges when you get to be a certain size in terms of having a homogeneous environment like you discussed. Yep. So, we didn't even get into VPD or greenhouse environments. And as someone who has a greenhouse, I did have some questions for you on that. Maybe I could do a follow-up interview with you and discuss some of those topics and also get some questions from listeners.
Absolutely. That'd be awesome. I mean, greenhouses can be a completely different topic and set of parameters. I mean, ultimately, we're controlling the environment, of course, but once the sun comes into play, it's a game changer. It's definitely worth its own conversation.
Yeah, I know I have a lot of challenges growing tomatoes and cucumbers and peppers in our greenhouse, and in terms of regulating temperature and environment. So I look forward to chatting about that, but I don't want to make this particular podcast too long, but I would love to follow up. So if that's possible, Sure. I will reach out here again soon and be in touch.
That sounds great.
That was Nadia Sabeh, also known as Dr. Greenhouse. You can find her on Instagram under the handle Dr. Greenhouse. Be sure to give her a follow because she's always offering new classes and speaking around the country. And I will be doing a follow-up with her, but it's going to be a month or so out due to scheduling conflicts. I am looking forward though to going more in depth regarding greenhouse management and VPD. You are listening to the Cannabis Cultivation and Science podcast. I'm your host, Tad Hussey. I'll post pertinent links on the podcast page at www.kisorganics.com. Just click on the podcast link. And don't forget to check out our blog page for more information as well. And if you're looking for soils or soil amendments or fabric beds or blue mats for your facility or garden this season, please hit us up through our website contact page or TAD at kisorganics.com. Thanks for listening.